Okay, so let's take a look at example 3 then. This is one of those just like example 1, where it's not a trinomial over a trinomial. It's actually just a monomial over a monomial. This is just a simple one. So if we take a look at this, again, there is no factoring to do here. However, if there's no factoring, that means we keep this all the same. So 7jf and all over 8k divided by 21j squared f squared all over 16k cubed. And then if you take a look at coming up with the restrictions, because that's the next step, the restrictions means the denominators can never equal 0. So this 8k, that cannot equal 0. If you divide both sides by 8, that just means k cannot equal 0. You're going to get the same thing over here, because 16k cubed cannot equal 0. That still means k cannot equal 0, because 0 times 16 will make that 0. So that's all the restrictions you would think right now. But remember what it said. The restrictions also include the numerator of the second fraction. Why? Because on the next step, when you go to multiply this out, this will be 7jf all over 8k times, or multiplied by, the reciprocal, which is 16k cubed all over 21j squared f squared. And so now you have to revisit your restrictions here, because this is now the denominator of the problem. That's not the denominator, but this second numerator becomes the denominator. So that j squared, that cannot equal 0. And if you take the square root of both sides, that just means j cannot equal 0. So there's another restriction. That f squared, that cannot equal 0. That means f cannot equal 0 if you take the square root of both sides. So these are also restrictions. This is why it says in step 2, when you go to do restrictions on a division problem, not only do you look at the two denominators, but you already know that the second numerator becomes a denominator, so you have to state the restrictions right away. Or you can revisit them when you get there. So then it asks us to just multiply straight across. So multiplying straight across, if I do this using a calculator or whatever, 7 times 16 is 70, 112. And then jf times k cubed is jfk cubed. And then I have 8k times 21j squared f squared. And so 8 times 21 is 168, I believe. And then k times j squared f squared, I'll write it in the same order. J squared f squared k. Okay? So if I have 112 over 168, I can reduce that. Both top and bottom, you could use your calculator, it's fine using the fraction button. Both top and bottom are divisible by 56. So if I divide the top by 56, it's 2. And divide the bottom by 56, it's 3. And then if I take a look at my j's, so I took care of that. Take a look at my j's, that's j to the power of 1 divided by j squared. Again, if I try to cancel these out, what's going to be left? Well, there's one extra j on the bottom than there is at the top, so that's what will be left. And then if I have f to the power of 1 divided by f squared, again, trying to cancel these out, there's one more f on the bottom than there is at the top. So there will be one f left at the bottom. And then my k, this is k cubed divided by k to the power of 1. If I try to cancel those out, again, there are more k's at the top. There are 2 extra k's on the top than there are at the bottom, so you'll be left with k squared at the top. And this will be my final answer. So this is just a monomial times another monomial. This is a little different from doing the trinomial questions. So let's take a look at the trinomial question. And you got to be not only at this level, but you got to be able to do this and also be able to understand what kind of factoring you're going to always use. Because sometimes it'll be just a common factor, sometimes it'll be a difference of squares, sometimes it will be a perfect square trinomial or a complex trinomial factor by grouping. Anything is fair game. So if I take a look at this, I have x squared minus x minus 20 divided by x squared minus 6x. So the first thing is I'm going to rewrite this except with everything factored. So at the top, I just have a simple trinomial. So the product of that thing is negative 20, and the sum of that thing is negative 1. Two multiples that multiply to negative 20 add to 1. Negative 1 is negative 5 and 4. And so this will leave me with x minus 5 and x plus 4. The bottom here is not a trinomial, it's just a binomial. And I can actually take a common factor. That's what we should always check. Common factor of x. So I can factor out an x, and this divided by x is x, and this divided by x is negative 6. So you have to remember to take a look at just common factors. Then my next one, over here, I have x squared plus 9x plus 20. If I use product sum integer rule again, because that's just a simple trinomial, the product is 20, sum is 9. Two numbers that multiply to 20 add to 9, 4 and 5. So this is x plus 4, x plus 5. As you can see, I'm actually going very quickly when factoring. I'm not explaining the process of factoring any longer because that's a grade 10 concept. And at grade 11, you got to be an expert at factoring, so this comes very quickly to you. So the next one, the product of that bottom one, it says x squared minus 12x plus 36. The product is 36 and the sum is negative 12. So the two integers that multiply 36 add to negative 12, negative 6 and negative 6. So that actually was a perfect square trinomial. But as I mentioned before, it's almost pointless to check if a simple trinomial is a perfect square trinomial, because by the time you're done checking, you could have already finished factoring the thing. It's always better to check to see if a complex trinomial is a perfect square trinomial, because then you'll save yourself factoring using decomposition or even the crisscross method, even though that way is easy. So then the next thing you're going to do is you're going to state the restrictions. So stating the restrictions, you got to remember, stating restrictions for a division problem, you have to state the restrictions of both denominators and also the numerator of the second fraction, because that second fraction will become flipped when we multiply by the reciprocal, right? That ends up being the denominator. So I'm going to take care of that now. So the first factor, x cannot equal 0. That's good. The second factor, x minus 6, that cannot equal 0. That means x cannot equal 6. Now some of you may just be able to look at this, okay, x can equal 6, x can equal 6, x can equal 6, x can equal 0. That's fine if you write that right away. Also, that, again, I don't have to restate that. That's x minus 6, x minus 6. I don't have to restate that one. But this one here, remember, numerator of the second one, x plus 4, that cannot equal 0. That means x cannot equal negative 4. And the last one, x plus 5, that cannot equal 0. That means x cannot equal negative 5. So those are my restrictions. You either get it wrong or right. So you can't have too many, you can't have too few. Then I'm going to multiply by the reciprocal. So I leave this as this, and I multiply by the reciprocal of this one, x minus 6 times x minus 6, all over x plus 4 times x plus 5. My next line will be very easy. Will just be the exact same as you see here, except one complete line. It will be x minus 5 times x plus 4 times x minus 6 times x minus 6, because that's how you multiply fractions. And this will be x times x minus 6 times x plus 4 times x plus 5. And then I go and cancel out any common factors, because these are all factors being multiplied by each other. So now I can cancel things out. For instance, this x plus 4 divided by that x plus 4 is gone. This x minus 6 divided by that x minus 6 is gone. Please do not attempt to cancel out x minus 5 divided by x plus 5, and that's somehow negative 1 or something like that. That's incorrect. You can only cancel out brackets if they're exactly the same. So our final answer here, after I cancel those things out, on the top I will have x minus 5 times x minus 6, and on the bottom I will have x times x plus 5. And this is my final answer. I can't go any further. So again, gotta understand that factoring is secondary here in this lesson. You have to be able to factor quickly, precisely, right? You gotta be able to state restrictions. So the restrictions, again, the denominators can never equal 0. Well, that's fine for a multiplication problem, but for a division problem, just remember that yes, the denominators can equal 0 and the numerator of the second fraction, because that becomes the denominator later on in the question. State your restrictions, multiply all the factors together, and don't actually expand the brackets, but cancel out the brackets that look the same, because it's all multiplication now, and division, it doesn't matter what you do first, and then write down what your most simplified answer is, which is that, okay? And that's it. So just remember that these can also be complex trinomials up there, or perfect square trinomials, or any type of trinomial or binomial. Always check your common factor first, and then just factor appropriately.